Hello, everyone. I am very pleased to welcome today William Ritchie, who is the CTO of Custocy, which is a French startup specializing in AI NDR. And we're going to do a brief introduction. I'll let William introduce Custocy, what they do and what makes them different. Then we'll do an introduction to the technology and again, what its differentiators are. And then we'll talk a little bit about the new partnership that was just signed between Custocy and Enea. It's a technical partnership for our network traffic inspection tools and our threat detection software development kit to be integrated into their solution. So welcome, William.
Hi, good to be here.
Wonderful to have you here. So first, can you tell everybody a little in your origin, who you are, and what your ambitions are?
Sure. So Custocy was founded in 2018, and it was a spin-off of a security service provider called IMS Networks. And what they realized at the time was that there weren't any good actors, or at least not sufficient actors in the network detection space who could use behavioral analytics to find threats in the network. And they wanted to breach that, and they wanted to, sort of come into that space and create their own tool because they weren't satisfied with what was on the market. And so they started Custocy in 2018. And since the beginning, the focus has really been on trying to not use signature-based analytics. It really has been on trying to look at behavioral analytics and try to use AI because, I mean, as everybody knows, signature-based attacks have their limits because the attackers, of course, have them as well, and so they know how to sort of go around them. And as well, they wanted to be able to prevent or detect zero-day attacks. And so they really focused on artificial intelligence from the start. And that's why we started off with really strong collaborations with academia in artificial intelligence. And we kind of built our whole stack from bottom up, from AI. We sort of thought, what's the best AI we can use to detect threats in the network? And then we'll build all the other stacks up from that.
Very good. Excellent. Thank you. We'll come back to those technology attributes that you just mentioned, but a little more just about Custocy in terms of the market. Sort of what is your strategy for development vis-a-vis the US and Europe and just your growth plans?
Sure. So Custocy, we want to be a pure player in network detection, right? So we want to, I mean, our philosophy was we want to have the best detection in the network. We don't want to go into EDR or XDR. We don't want to do into other functionalities. We really want to stay into network detection. So our philosophy is to integrate well with other partners and to be able to integrate with SOARs, CMs, or XDRs, so other much broader solutions. But for us to always stay in the network category. This is what we do, and this is what we do well, and we want to stay there. So for the moment, where most of the people who have our solution are based in France. So these are medium to large sized companies. We have some hospitals, localities, we have small enterprises. And we're currently looking to go into Europe and in the years to come, of course, the US.
Excellent. Very good. Now let's move on to technology. You have something called a MetaLearner and a multi-temporal use of AI. And could you explain what it is that does? And two, if it could help alert fatigue, frustration with the difficulty prioritizing alerts with burnout and turnover. I mean, every survey that touches on cybersecurity professionals almost that tops the list, it is so stubborn. So as you explain what MetaLearner is and your approach, maybe you can talk about too, what it brings to the frontline cybersecurity professionals.
Sure, absolutely. So when we started out in 2018, lots of the detection that we were doing was based on net flows. So flows between basically two assets and looking at whether this was suspicious or not. And then we realized that an AI that was based only on net flows was limited because it couldn't see the scope of what was happening across multiple hours or multiple days. And for example, if somebody's trying to exfiltrate data, very slowly, gradually, so it's not suspicious, you won't be able to see it in the net flows. In the same way, if you have a distributed attack and that distributed attack is obfuscated, or if there are ways that they're using to be more subtle, you won't be able to see it just in net flows. So we thought, if we want to be able to see internal scans or distributed attacks, we have to be able to aggregate multiple net flows and have an artificial intelligence that looks at multiple net flows on a network. And then we thought, yeah, but wait, that's not enough. So we said, we have to also look at the behavior of different assets, and we have to learn how they behave every day of the week, what sort of protocols they use, how do they use them, in what volume. So we said, so we actually need something that looks on a daily basis, on a weekly basis, that learns the biorhythm of a network. And then we thought, well, wait up, there's also a really good way to detect if traffic is encrypted. There's really good techniques based on packets, just looking at individual packets, how their size, their direction, to try to find command and control beaconing or to try to find exfiltration. And we thought, so we have a really good technique to detect command and control that's based on internet packets. So that's millisecond, We have a good AI that can detect at the net flow level. We have a really good AI that aggregates net flows and can detect scans and distributed attacks. And then we have this thing that's based on behavior that's like across weeks and months that looks at how you are behaving every day. And we thought, well, wait, that's 4 AIs. And so we thought, well, why don't we combine those? Instead of feeding all that information to the end user, why don't we say that we have another AI above that? And the role of that AI is to look at all those inputs. So the input that's coming from a millisecond AI, the flow AI, the aggregated AI, and behavior. And all of these are on different timescales, right? One of them is millisecond all the way up to a weekly how you use your computer kind of analysis. And so what this MetaLearner does is that it takes all the output from these different artificial intelligences we have, all these different models, and it is the one that decides. In the end, it says, all right, I think there's something wrong because I've looked at this at the net flow level, and now I know your behavior on a Monday morning at 10, and given all this information, I think there's a serious problem. And so that's called model stacking. So basically where you take multiple AI models and you stack them one on top of the other, and their output, instead of going directly to an end user, goes to another model. And that model says, all right, there's something bad or there's something good. And the result of doing that was that we had 88 times less false positives than if we were just based on the net flow level. And our sensitivity of detection was as good, if not even better, just with net flows. So this is a really good tool to prevent fatigue, because it means that, number one, the user doesn't have to look at hundreds of panels. It doesn't have to look at the behavior analytics. It doesn't have to look at net flow analytics. It can just look at the MetaLearner. And if the MetaLearner says there's something wrong, you investigate. If it doesn't say there's something wrong, don't even look at the screen. Don't worry. So not only did we find a way to make a detection very sensitive, but we also found a way to reduce false positives. And so from then on, it was a back-end nightmare to sort of implement, because all these AIs run at different timescales, and we thought, oh, well, how are we going to do this? And we gave that to really good back-end engineers, and they were just like, this is awful, but we still did it. And the end product is really good, because the only thing that the AI is telling you is, yes, you have to look now. I'm feeling concerned, or no, don't look, don't worry. And that's what they want, is just a simple screen. And basically the screen has a skull on it if there's something wrong. And if there's nothing wrong, there's no skull. And sort of, instead of having an analyst look at all these graphs at different time levels and different statistics, having an AI that can sort of supervise all that and only alert you when it's serious was a really big, it was a really big advantage we had over other solutions. We had to monitor multiple screens and multiple plots, multiple graphs.
Wow. Well, that sounds like that could really make a difference in terms of.
So I can talk about it a lot.
Because again, it's huge and it's incredibly persistent. At the same time, with what you're describing for some of the bosses of the frontline people, they want to know, well, this is awesome, but what's really going on? So, what is your policy regarding transparency and explainability of what it is that you're developing?
Sure. Personally, I come from a background of AI in medicine. And the first thing that I noticed when we were looking at current solutions that were on the market was that there was a clear lack of explainability and interpretability, meaning that most solutions would not tell you why the AI came up with that solution, and it wouldn't help you interpret that. And this in medicine is just absolutely not possible. Of course, if somebody tells you you've got something wrong, you want to know how and why.
Yeah.
And so this philosophy of transparency is what we brought into Custocy. So basically, when an AI says it's going to make a decision, you can then go and investigate. You can really drill down through the interface and say, oh, it's made its decision based on these criteria. It's got a false positive rate of this, and this is how it interprets that data. And it really allows you to understand really how the model works all the way down. You can drill down to look at what type of model it is, what type of neural network it is. But most people just stay on the surface of saying, well, in this particular attack, what allowed you to find that? So that's really helpful. It can say, well, what allowed me to find it is that the net flows coming into this asset are very regular. So this conversation is very regular. It's happening every hour. It's pinging. It's the same type of data that's coming through. This is suspicious. You've never done this. We find this suspicious. And so a lot of what we do is based on transparency and explainability.
Excellent. Thank you. Well, I can see we're starting to head towards why this was a natural fit, this partnership between our technology and your technology, whereas our product with our deep packet inspection engine, Qosmos ixEngine, it has the broadest and sort of most relevant protocol coverage, but as well extraction of really rich metadata, 6,000 kinds of metadata, and it's looking at network flows. And we find that all the time, that not only can really look at what's happening, that it's so easy to fake logs and to tamper with all these other sorts of sources, that that's a ground truth of what's going on, that not only supports network protection, but of course all other kinds of threat detection. So in terms of what you were thinking of, particularly being machine, AI oriented, what drew you to using to pairing with the classification engine that we have, as well as that threat detection kernel, which we'll talk about a little bit more.
Yeah, sure. So, I mean, the first, our interest wasn't actually first with the AI. It was actually first with your performance. The performance was really good. And so we were looking at, 3 times less compute power using that solution. And we're like, that's on a performance level, it looks really good. And when we started investigating it and we started using proof of concept on your product, we were sort of saying, oh, wow, actually the classification of level 7 protocols is really good. And so that's when we thought, well, we really need this. It was a performance thing first. And then when we started looking at, the granularity, the finesse, and how correct it was in classifying protocols. And that's essential for us, mainly for our behavioral analytics. So that AI that looks at what you're doing at different days of the week. Because what we had before was about 60% of our traffic was put into the box unclassified. So between 30 and 60% of traffic was unclassified. So our AIs was kind of saying, well, this is difficult, guys. This is a difficult task. You're asking 30 to 60% is unknown. And when we moved to Qosmos, we found that all of the traffic was classified, and the granularity with which we could classify it was so refined. And we could classify it into different types of usage, and that allowed us to cluster assets. This is saying this is like a personal PC, this is a web server, this is a calculation server. And we found it straight away. So when we would make a clustering map of all the assets, before the assets were pretty much split up everywhere, we could find these little clusters and it didn't really work. And now they make these beautiful separated out groups, and we can say, this is how these people work, these group of assets work like that. And it really allows us to get a better picture of the behavior of these assets and groups of behaviors within a company. And so that really was, for us, it was, the decision point. We said we can't do without this. It's the way we cluster assets, the way we can predict behavior is so much better.
Awesome. That's wonderful to hear. That'll make our product and research team very happy to hear that. And it sounds like a confirmation of a very old adage that you can have the greatest sort of models and the greatest algorithms in the world, but always the quality of the data is an equal partner in the success of any AI or any machine learning project.
Yeah, of course. And then you have all the added bonuses of retrocompatibility, and the documentation is fantastic. I mean, it was just such an easy integration. It really was such an easy integration. When we did the proof of concept, We'd planned for a whole sprint cycle, so 3 weeks. And at the end of 3 days, it was done. We're like, wow, this is really good.
That is awesome. That is fantastic to hear. And I know our teams are thrilled about this partnership, and we're looking forward to exploring some of these topics in a little more depth with you. We are absolutely looking forward to the adventure from here, and thrilled to have you on board as a partner, and look forward to the next round of discussions.
Yep, absolutely. Looking forward to it.
Wonderful. Thanks very much. We'll see you
Thank
all
you.
soon.